Hi guys, I hope you're doing well. In this video, I will show you how to perform multimodal RAG using Gemini. And for those who are not familiar with the term, RAG stands for Retrieval Augmented Generation, and you will see how to perform RAG using Gemini, VertexAI vector search, and LangChain. But before going deeper into these concepts, let's have an overview on some of them. So RAG, as you know, became so popular because it enables LLMs to access external data. So this adds more information compared to the information that the model already has, that it gained from its pre-training. So in addition to this pre-training data, we add external data present in databases or data stores. Also, by giving the model additional data, we mitigate against one of the biggest problems of LLMs, which is hallucination. What is special in this notebook is that we will talk about multimodal RAG, where we query documents filled with both text and images. And having both information from text and images provides a richer and more comprehensive knowledge for the LLM. Also, adding visual cues improves the LLM reasoning capability. So to summarize what we will do in this notebook, we will extract and store metadata of documents containing both text and images. We will search the metadata with text queries. We will search the metadata with image queries, and we will use text query to search for contextual answers using both text and images. It's enough, guys, talking about theory and concepts. Let's have our hands dirty now. So first things first, you need to start with installing packages. I will not rerun the cells here to gain time. Once you install necessary packages, you need to restart the current runtime to be able to use the newly installed packages. You need authentication, and you need to fill in with GCP information. So here we suppose that you already created an account on GCP, you've already created your project, and you have all this information, which is project ID, location, GCP bucket, and so on. Here I have another video where I explain how to go through all these steps, and the good news is that you have $300 of credit from Google so that you can play around with all this stuff. Once you create your project, you need to initialize the VertexAI SDK. So once you initialize it, you will go through some authentication steps, but it's very straightforward, guys. You just need to follow the steps. Now here we import necessary libraries. Here is another package that you might need to install, and here are some information related to the model that we will use to perform RAG. So here, for example, we will use Gemini 2.0 Flash, the output token limit, the embedding that we will use, embedding token limit, and so on. Here we download the repo that contains our data. Now for the data, we will use a smaller version of the Google 10K file, and the original file provides a comprehensive overview of a company's financial performance, business operations, management, and risk factors. So what you need here is to put the path to the file. So here we have our file on Google Drive, and we will use the partition PDF method to extract text from this file. So here I'm extracting text and I'm passing the images and tables separately. That's why I'm putting extract images in PDF to false and infer table structure to false as well. If you put them to true, it will take far more time to process the whole PDF. And here, these are other parameters. Very quickly, if we look at some documentation related to these parameters, so for the max characters, it chunks elements of text or text as HTML into chunks once the max is reached. The new after n characters, it creates a new chunk once the number of characters is reached. And the combined text under n characters, it actually combines text which are under a certain limit. Once we have our raw PDF elements, we go through all these elements, which are text in our case, and we append them to the text list. We define a splitter, which will split the text into chunks, and we even precise the chunk size. We join all the piece of text that we have, and we use the splitter to split the resulting text. Just to have an idea, if we check how many chunks of text we have, so here we have 5 chunks of text in total. So now let's look at some functions that we will use later on. So here we are summarizing text, and to give you more context, guys, we are summarizing the text and the images, and later on we will use the summaries to search information to answer to a certain query. So here is our generate text summary function where we use an LLM to summarize text. So here we are asking the LLM to summarize text, and that we want our text to be optimized for retrieval. Once we define the prompt, we inject it in a prompt template. We define our model. The model name is already defined in the beginning of the notebook, and we create our chain. So our chain, which is composed of the input, so the element will be injected in the prompt. That's why we had element here. This prompt will be passed to the model, and the model output will be passed to our parser. Once we have our chain defined, we use to generate summaries text in batch mode. And here we call our function on our texts. As we did for text, we need to summarize images as well using an LLM. The prompt is slightly different. We are asking to summarize images for retrieval, and we are precising if it's a table. We are asking the model to extract all elements of the table. If it's a graph, to explain the findings in the graph. We define the model and we parse images one by one. We encode the image. Once the image is encoded, we now have all needed elements, which are the model, the encoded image, and the prompt to generate our summary. So if we take a look at the image summarize, it actually invokes the model with the prompt and the encoded image. And here we call our function on all the existed images that we have. And here in our case, all the images are actually the tables that I converted to images and the charts that we see here, like this one. And we will use all this information alongside with the text to retrieve information to answer to the user query. If we take a look at the image length, so we have in total 11 images here. Now we have our text images already summarized. What we need now is to store all this information in what we call a vector store. And alongside with the vector store, we need to create the index as well. So once our index is created, we deploy it on GCP this way. And now we have all what we need to create our vector store. So we pass the project ID, location, the index name, and the index endpoint name. And also we pass the embedder that will be used to embed our document. It's to be noted, guys, that we could have used a local vector store like Chroma, but I've already showed this method in other of my videos. So I wanted to show you how to create a vector store in the cloud, and it might take a while, guys, creating this, so that's why I'm not running it again. Now, guys, in our case, we will use a multi-vector retriever. In this multi-vector retriever, we will store the vector store, which will contain vectors of our documents, and we will use a doc store. So here, the reason for which we are using both is that this way we will be able to associate each raw document. So in text, for example, or the image summary, we'll be able to associate it with its embedding. So this multi-vector retriever needs to be populated with documents and embeddings. The embeddings will be created using add documents, and they will be stored in the vector store of our multi-vector retriever, and the doc store will be populated by the doc contents, which groups text and the list of images. So here is the list of the encoded images. And this way we have our multi-vector retriever populated with embeddings and raw data. Now, guys, we have everything to perform RAG, multimodal RAG, where we use text and images. So what we need now is to define the chain that includes the whole process to have an answer, and we call this chain with the user query. So let's take a look at the final chain. In this case, we call it chain multimodal RAG. This chain will contain the context and the user question. The user question will be the user query that we will use to return relevant information to answer to the query. And this relevant information will be in the context. Now, to have this context, the user input will be passed to the retriever. The output of this retriever will be the relevant documents to answer to the user query, and we pass these relevant documents to this function that we call split image text types. So what this function does is actually parsing the relevant documents and separate them into images and texts. Once this is done, the resulting dictionary will be given to this function. So let's look at what this function does. So this function takes this dictionary, takes the text part of the context, and appends it to a list of messages this way. So here we are giving the prompt to the model, we are passing the question of the user, and the context will be formatted texts. If we have images as well in the retrieved documents, we add the image to the message list. And as a result, we will have messages with text and images in the good format needed for the model. Once we have the complete messages, we pass the resulting list to the model that we defined in the beginning. And at the end of the chain, we add a string parser. So this way our chain is defined and just needs a user query. So in this case, let's try out this query. So here we are asking the model what are the critical difference between various graphs for class A share, which index best matches class A share performance closely where Google is not already a part, identify key chart patterns from Google class A shares, and so on. So we have all this information that we are asking the model to provide us, and be sure that knowing that the already provided documents, the text and images contain the answer to this query. Now we query our chain with this query, and here we have our answer to our queries. It's kind of not bad answer, it's kind of detailed. And answers are going from 1 to 10 because in our query we asked actually 10 questions here. So the model went through all information, retrieved relevant information to answer to this question, and it gave us a quite good answer based on text and images that we provided. And here we can even print the relevant documents that the model used to give us the answer. So this is it guys for today. I hope you liked the video. In today's video, I showed you how to perform multimodal RAG to retrieve information from different types of data, which are text and image in our case. Again, in this video, I showed you in purpose how to create and deploy a vector store in the cloud and not necessarily using a local vector store that I've already showed it in other videos. I hope you liked the video. Please don't forget to subscribe to the channel. I will put a link to this notebook in the video description. I will put links to other relevant videos as well. Thanks for watching. Please don't forget to subscribe to the channel and see you next time.